How's everyone doing? You're back with Jono for another quick math lesson. Today we're going to look at our unit circle again, but specifically we're going to look at the exact value of some of our trigonomic functions. And we're also going to see that these sometimes are hidden within our unit circle, so we can find some extra information for free if we know where to look. So in the last lesson we looked at the x and y coordinate on a unit circle are defined by the angle of elevation of that point. So if we've got the x coordinate, that is equal to cos theta, and the y coordinate, or how far up and down, is equal to sine theta. If you're not 100% sure on how I got there, please have a look at my last lesson, because I think it will be really helpful for this one. We also need to know that anytime we do get a coordinate on this unit circle, it's going to be between -1 and 1 for both x and y, because the circle has a radius of 1 and can't get out of those parameters. So for some of the common angles, it's actually super helpful to know exactly what they equal to, because then we can use these very quickly to find out a bit of information in a lot of different scenarios. So our common angles are 0, 30, 45, 60, and 90. And I'm just going to draw why they're important or common now. So the 0, I like to think about it, is like the start. We start down here, and this line from the origin to that point of the x-axis has no elevation, so it's the start. As we go up, 30 degrees is a third of the distance of this quadrant, right? We know that the quadrant is 90 degrees in total, so 30 degrees is just 1/3, 45 is halfway up, 60 is 2/3, and 90 is this one straight up, where there is absolutely the whole way of that quadrant is done. So we've kind of finished all the information that we could find from this one. So I am going to go through what these exact values are. There are some really good videos on tricks to remember these using your hand on YouTube already. I'm not going to do that. I'm just going to go through them quite quickly with what I use in order to remember them. But if you are looking for an explanation of them, I've linked some videos in the description below that I think will really help you out. So the way that I remember these, that the cos and sine are complementary of each other. That's actually what cosine means. It means complementary of sine. So in each one of these, they're going to be the opposite. And we can see here that cos 0 is equal to 1 and sine 0 is equal to 0. This actually comes from the unit circle before. If I've got 0 degrees of elevation, I'm all the way over here. And that means that cos of 0 is all the way over here at 1. There's no elevation, which means sine 0 has to be 0. And that's where this point comes from, because it is actually the point 1/0. Cos theta is x, so cos 0 is 1. Sine of 90 is up here, and that has the exact opposite relation. X hasn't moved, so cos 90 has to be 0. But it has gone all the way up, so sine of 90 has to be 1. And we can see in our table that they are complements of each other. So cos theta is equal to 1, sine theta is equal to 0. At 90, or the exact opposite, these two numbers switch. So the way that I like to remember these other ones is that they're all a root and they're all divided by 2. They also count down in a really sequential pattern. So cos 30 is equal to root 3 over 2. So root 3 divided by 2. And then as we move down one, the only thing that changes is we count down. So instead of root 3, we now have root 2. So this is root 2 over 2. And then cos 60 counts down one more time. We have root 1 over 2. Root 1 is just 1, so you can write a half. And now, because these are the complements of each other, we just have to go the other way to go up. So sine 30 is equal to root 1 over 2, or 1 over 2. Sine 45 is equal to up 1, so root 2 over 2. And then the last one, sine 60, is equal to root 3 over 2. So what we've got to remember is that each one has a root on top and is divided by 2, and they count down or up, depending on which one you're looking at. So you might be thinking, why does this help, right? It's a skill that I can just type into my calculator every time, but it does become really helpful when we have hidden triangles within our unit circle. So this one over here is a degree of 135, which is way more than we've talked about. But there is always a triangle made between the point and the x-axis. We do have to make sure we're using the x-axis as our reference point. That's incredibly important. So there's this triangle is inherently made from us having a line at 135 degrees. Because that's gone from 90 to 135, we know that this angle is 45, which also means that this angle is 45 as well. Well, you've just told me what sine and cos 45 are, but now this triangle is just on the other side. So we've actually done all the work. We don't have to remember anything more than 90 because the pattern just repeats itself. The only thing you have to be wary of is you need to know whether cos or sine is going to be positive or negative given that coordinate. So up here, I know that sine or the y is going to be positive and cos is going to be negative. So this point here, looking back at our table, 45 is root 2 over 2 for both of them. So the cos theta, or cos of 45 in this example, is going to be negative root 2 on 2. And the positive sine coordinate, the y place, is equal to root 2 on 2. And you can actually check this in your calculator. If you type in cos 135, it will give you the answer negative root 2 on 2. It will give it in decimals, but it's equivalent. And if you put in sine 135, it'll give you the same number, but positive, which we've already worked out. Just one more here, we've got this. 240 degrees is a reflex angle. Again, you have to make sure you're using the x-axis to make this triangle up. So we have a triangle that's here. We can see that it's gone from 180 all the way to 240, so this angle must be 60. For this reason, we can work this out incredibly easy. We've got cos 60 and sine 60 basically, but both are negative. Cos 60 is 1 over 2, so the x-coordinate here is negative a half, and sine 60 is root 3 over 2, but again, it's got to be negative, so this is negative root 3 over 2. So this is a really helpful skill because it'll let you kind of know exactly what the coordinates are going to be without having to use your calculator. Quite a lot of the questions you'll get in exams will use this concept, but ask you not to use your calculator. So you do have to make sure that you know what's going on when we draw them out. This will come in handy in advanced maths where we're looking at sine and cosine waves. But for the moment, if you can do this, I guarantee you're going to find the rest of trig super easy. Thanks so much for watching, guys, and I'll see you later.